Okay, everybody. Thanks for joining me for this full build and construction considerations video I'm doing on the batch rocket masonry heater I built last fall. Basically, I'm doing this video for myself like 4 months ago and trying to go through things that I wish I would have known back then that I know now. And there's a lot of considerations in terms of how to make everything be of the right size so it's functionally okay, and that sort of things. So let's get into it. The agenda is, firstly, I want to talk about why a masonry heater in my case, because I mean you have your J tubes and you have whatnots, but in my case a masonry, so why I chose to build a masonry heater. Then I'll go into the building considerations and reasons why I did what I did. Then a full build. So I'll just go through the build. Basically, this is also an addendum to my time-lapse video. So if you haven't seen that yet, go ahead and have a look through it. And you'll have some sort of a inkling of what I'm talking about today. And then question and answer session at the end. Now, I've written down here that the information herein is by no means anything more than a description of my specific build, and as such it should not be considered advice in any way. And take that with a grain of salt or a ton of salt. I'm just a hobby builder, not a real mason, so I don't really know the tricks of the trade. I'm just a self-learned YouTube guy. But anyway, I want to share my experience. Now, why did I go along with the masonry heater? It's traditional where I live. Most of the heating equipment here, when we're talking about burning wood, you have metal stoves for burning wood for the sauna, and then you have in the cottages you have some kind of metal stoves like your Franklins and what have you in the United States for quick heating. But traditionally in Finland we use masonry heaters, so it's the traditional way of going about things. The second thing why I did want to stick with that tradition is that I actually made this heating unit for my hen house. Now, with all of the dust flying around from the hen house, even though it's behind a closed door, anybody who has chickens knows how much dirt and dust you get from there. I didn't want to have any cherry red hot barrels with dust in the same space. So also the masonry heater makes a lot of sense in that sense. Storing heat through the mass. I don't want to be burning on and off all the time. Rather, I want to have one burn in the morning, and all of the rest of the day the heat will dissipate from the mass. So that's a big plus in my consideration. Now, in terms of thinking about where to have a masonry heater, you need some kind of foundation, a strong foundation at that. And I had no restrictions in that sense. I'm on the ground floor, and as you'll see in the build, there's no problems there. So obviously that's one thing that you need to be thinking about when you build yours. Do you have a sturdy enough foundation? I did, so I could. The other thing is building permits. Here where I'm living, there's no problems about doing built on site masonry heaters. Yeah, for the flue and the chimney you need permit, but as to the building of the unit itself, there's no real problems there. This might be different where you live, but here in Finland, that's how it goes. So that also is a consideration, and for me it was green light on that area too. And then lastly, at least lastly in the sense of the things I was thinking about, the masonry heater is an easy way to tailor the sizing to your needs. So if you want a bigger heater, buy more brick. If you want a smaller one, buy less bricks. And it's quite easy to do your sizing based on what you actually need. And I'll go more into that sizing aspect, of course, later on. But that was one of the things. So yeah, I ended up doing a masonry heater for me and my chickens. Then the second question is, after masonry, why rocket? Well, rocket stoves seem to be the new way. It's like the new black in heating, and they're extremely efficient, and the emissions are extremely low. A pure burn on a rocket heater is basically zero footprint in terms of anything escaping there. So you don't get any soot into your flue, so there's no chimney fire hazard. Also, you actually, in those places where you're allowed to do it by code, you can actually have a chimney that isn't as high temperature spec'd as what we have to have here in Finland. We need something called T600, and you could go way below that at T250, something like that. Those are temperatures centigrade, so 600 degrees here, because the efficient burn and the way that the rocket stove is built, you actually end up dissipating the heat directly before the flue, before the chimney, either into mass, in my case, or into a cherry red hot barrel as the bell. So there is real value in having an efficient burn with low emissions. I mean, you can't have somebody tell you that you can't build a heater and burn wood because you get emissions from wood. In these cases you don't. It's really a clean burn. And why batch? Again, you have two ways of looking at the rocket stove. Either a straight rocket where you don't load batches of wood in, or then in my case it was just a no starter, no brainer. I definitely wanted to do a batch rocket. I don't want to be continuously feeding firewood. Like I said earlier on, I want to do one burn in the morning and on a really crystal cold night too. But that's the extent of it. So one burn has to do the whole day, and I can't be watching there any escaping sparks in the dusty room, remember? So I couldn't be there watching the fire. And again, batch is tradition here in Finland, so a no-brainer there too. So that's why I went for a masonry Batchbox rocket. You might also want to question the opposite angle. Why wouldn't one want to build a masonry batch rocket? For me at least, bricklaying is a daunting task, and it's probably that for many others out there like myself who don't have any experience in bricklaying and who haven't ever basically laid a single brick in their life. Now take that into the case of buying a fireplace. it becomes even more daunting, even more frightening. So you do want to think through whether or not you're up to it, and if you are, go for it. The other thing why you might want not to build a masonry heater is that the high costs add up quickly. The cost of the bricks and the mortar, they're not cheap, at least here. For the fire insulation around the firebox, you need vermiculite or something of that sort. Not at all cheap. The flue pipe itself, the chimney, those are pretty expensive. The ceramic wool that you need for it, again, not cheap. You need a firebox door and other metal bits and pieces. You know, the cost just adds on and on and on. And again, in the question of my case, the chimney is a ready-made chimney that costs. And then I had some leca gravel for the foundation, and of course the mortar there. So yeah, it's not cheap, but again, I needed it. We have a lot of electricity outages here, and at minus 30 degrees centigrade, I don't know what that is in Fahrenheit, but it's cold. It's pretty darn cold. You know, you don't want to be left out there. Let's see, minus 30 C in F. Let's see if we can get a quick answer. Yeah, that's like minus 22, so pretty cold. So you know, you don't want to be left in a situation where your chickens are turning into frozen chicken just because you don't have electricity, and therefore you need some kind of heating system. And yeah, I chose to go the masonry route. Now, thinking about the building considerations and the reasons I chose what to do, what I did, is that the basis what I went for was a 180 millimeter, that is 7-inch chimney size. That's the inner size of the chimney, the actual flue. And I looked at Peter van Berg's setup on his homepage. I'll just click real quickly there. Peter's page is batchrocket.eu if you want to go there, and I recommend it warmly. Now, he has a lot of these building instructions and sizing hints and rules of thumb here. So especially this bit that we're looking at now is what you want to be looking at. Here's a lot of sizing guide, and this is what I took as my basis. Now, I just basically decided that, okay, for my space that I want to be heating, and 180 millimeter, that's 18 centimeters size is good. And so I took that as the foundation, and all of the rest of the sizing actually then is based on that. For example, what area is needed for the bell based on this? We'll look at that in the next slide. The sizing of the batch box, what the size of the port should be, and the thickness of the port, what it should be. And all of these things come from Peter's website. The riser inside of the actual heater, I won't be going into why a rocket heater is a rocket heater. So if you want to have that kind of information, look into some other video. I'll just be talking about my selections here. So the riser, that needs to be 8 to 10 times the base figure, which is also to be found on Peter's website. And please note, you always need 30 centimeters clearance over the riser at the top of the bell. So you need to take that into consideration. The size of the bell and the inlet for the primary air and for the secondary air. This is a figure that I actually got from Matt Walker. He has an excellent video series on YouTube, Stove Chat, and just recently, I think this week actually, he mentioned the fact that you want to have a 10% primary air of the flue size, and then just shy of 10% for the secondary air. And these are definitely things you want to keep in mind. You need a lot of air for a rocket stove to work. Other building considerations is the foundation insulation. So yeah, you need a foundation to begin with, because you're building 1.5 tons of even 2, 3, 4 tons of brick on the foundation. So you definitely want to have a good foundation, sturdy enough to hold that weight, but you also don't want to leak any heat down from the foundation. So you want to have insulation there. So keep that in mind. Then you want to be insulating any flammable materials that you have on the back wall of your unit. In my case, I just stacked bricks into a wall. Your decision might be separate or different, but in my case, I did that. I have a gap of air, then I have my bricks, and then I have a gap of air again, and then the heater itself. Vis-a-vis the chimney, what you want to think about is that when you're building the chimney, the code expects that you don't have a break in the inner roof. So in my case, a ready built chimney, they were 1 meter bits. That's like 1 yard. So they were 1 meter bits, and I had to make sure that 1 meter would then be enough from just under the ceiling to the place where the inner roof made into the clearance of the attic. So you cannot have a break there, so you need to keep that in mind. And while we're talking about the attic, you also want to keep in mind the fact that you don't want to have any big roof structures where you're going to be building your chimney. So do your homework before you decide where you want to put your rocket mass heater. So go to the chimney first before you start building. Just a kind hint there. I showed you those measurements from Peter's site, and I just took a couple of them here for us to talk about. So here you can see that a 7-inch, that is 17.5 centimeters, but we don't have flues of 17.5. The ready-built flues in Europe are 18, 180 millimeters. So that's the next size upwards, and that's what you want to choose. But here you can see that the internal size, the internal surface area, ISA, is 7.2 square meters with 180 millimeters flue. So the internal area of the bell, so not the outside of the brick but the inside of the brick, needs to add up to 7.2 square meters. And when you're thinking about the area there, the riser diameter / internal surface area of bell excludes the floor, because the heat never goes down to the floor due to the fact that it'll start climbing upwards where the flue starts. So you won't be heating the floor, but of course there's a little heat dissipation there, and that's why you need to have the insulation there. You don't calculate the firebox either, because it's hotter than the rest of the bell all of the time, so it won't be sucking in any of the heat from the gases. So those are the things are not to consider in your ISA, but the rest, that is the ceiling and all of the walls of your bell, you need to take those into account, and those need to add up to 7.2 square meters if you're doing a flue of 180 millimeters like I did. If your flue is a 10-inch flue, then you need to have double that in your internal surface area. When you think about it, double that is a lot of area. I mean, that is a lot of area. So this is where all of the knowledge about how big a system you want to build really comes into practice. The consideration is the bigger you build, the bigger you build. And it's not just a linear curve, it's actually a faster than that curve. So please keep in mind that it might be better to build 2 masonry heaters than one big one. But then again, in your case, it might be different. There's a yardstick rule that Peter van Berg says that they had actually come up with, is that the cross-sectional area is the riser times 300. So you can sort of keep that in mind when you're thinking about what to build and how to build. Here's just a quick recap of what I did in terms of my build. So I just took the inches, 7 inches, and then the millimeters here. And these are basically the dimensions that you need to have. So the box needs to be almost 26 centimeters wide. That's a good 10 inches. The height needs to be almost 39 centimeters. That's a good 15. And the depth needs to be 51, almost 52 centimeters. And that's 20 inches. Now mind you, in terms of the box dimensions, you shouldn't be toying around with the width and the height, but the depth you can actually make deeper than what the minimum here is. What the maximum, the practical maximum is, difficult to say, but you can make it deeper. And this is of course a consideration when you're thinking about what sort of firewood you'll be bringing in. It might be that your firewood is, 60 centimeters. So maybe you want to make it 70 deep. In my case, it is almost 70 deep, I think. So I can put a 60 centimeter wood in there, and that's pretty handy. In terms of the riser dimensioning up here, the length of it, i.e. the height, because it's a riser, so you take it from the bottom to the top, it needs to be 1.3 meters, and that 1.3 meters you still have to put an extra 30 centimeters, around 1 foot, for the expansion volume inside the heater. So the top of the riser, you always have to put an extra 30 centimeters, 1 foot of clearance on top of the riser. In terms of the port, which is the area from the firebox where you go into the riser, it needs to be a specific size, and it needs not to be round, so it has to be square, so as to create turbulence when it enters from the firebox to the riser. The width has to be a good 2 inches, 65 millimeter. The height, in my case, almost 29 centimeters, that's a good 11 inches. And the depth, 2 inches. So that's, in fact, in my case, I used 2 boards of vermiculite, each 1 inch in thickness, and I just put those back on back, and that's what I made my port out of. Then for the secondary air, we have the P channel. The size is again here 65 by 20 by 20, and in terms of a P channel, that is in fact when you have a secondary air channel running on top of your firebox. This is something that Peter van den Berg came up with, and if you have it on the bottom as I do, it's actually not called a P channel, but I think that's a good nickname for it, so I'll just keep on calling it a P channel too. But in my case, I built it on the bottom of the box, the firebox, and it runs between 2 bricks there. For the full build, I ordered 5x84 red bricks with holes. Why 84? I don't know. There's a historic reason why in Finland we get them in batches of 84. So I ordered 5 of those batches, and something around 18 bags of clay mortar. I ended up using actually 340 bricks of the total, and this is for a heater that is 180 centimeters high, so that's ballpark 6 feet. And the full build was from September 19th to November 22nd, so quite a long build, but you know, I did it after the day at work, during the weekends and so on and so forth, so you know, it takes some time. And like I've written here, there are a ton of considerations when going through the build, and for me at least, the only way was to really take my time and doing my research, i.e. watch other guys doing the same thing on YouTube, and obviously not only YouTube but reading on the web. But for me, a total layman, I just couldn't go every day and continue the work. Some days I just had to do the research and nothing was built during that day. But at the end of the day, that seemed to work for me. So if you're anything like myself, go ahead, just take your time. And if you're one of those guys who already know how to build, then you know, you do it your way. Like I've written here, just basic things like how much mortar with water to mix to make it right for the bricklaying. You know, trial and error, rinse and repeat. That's the only way I got through it, and I guess that's the only way anybody will get through it. So you just have to learn by doing.